So today's week 13, and what we want to do today is we want to work with Web API. So let's just chat about this for a minute. What the heck does this mean? What is an API? How could we explain what an API is in non-technical terms? If you're going to go home today and your family or roommate said, "What'd you do in class this morning?" Well, we learned about APIs. Well, what the heck is that? How could you explain that to somebody who has no technical background in a way they could understand? Tyler, what would you say? Okay, so an API is a middleman between maybe two entities. That's a really good way of describing it. Anything else we might say about it? What are some common scenarios if we're thinking about building web applications where we might use or interact with APIs? Okay, could you give me so what would be an example of when we might do that? What kind of information and what kind of server might we want to retrieve something from? Okay, yep, so we want to maybe get traffic from the Ministry of Transportation, right? We don't have that data, but we want to use that data in our application, whether it's a web app, a mobile app, or something else. Rodden? Okay, absolutely. So we want to use functions that somebody else has written that they've made available. Can you think of a concrete example of that? We do that all the time. You're absolutely right. If this loads, so if I search the college website for something, this is using an API to run, and I can tell visually this is using what kind of function. I'll ask you first, what kind of function is this using that somebody else wrote? Yeah, it's using search. Whose search API is it using? Who wrote the search API that powers this page? You should, there's a visual cue. Jacob? Right, how do you know it's Google's search function? Right, because it looks exactly the same as the format of going to google.com or google.ca and running a search. And sure enough, if we scroll down just a little bit, ta-da. So Google makes its search API available for us to use. Why would they do this? Why is Google so generously giving the college its search library for free? Right, because A, data mining, and B, the branding right here. So Google's logo is now on Georgian's page. Plus, they're getting information about everybody at Georgian and what are they searching for, right? And if they're logged into their Google account, how old are they, what gender are they, et cetera, et cetera. So this is one of Google's most popular APIs. What other APIs does Google make available that we see used everywhere? Maps. Right? Think how much work it would be for us to generate our own map of something. Well, we're never going to do that. We're going to use an API like Google and let Google generate the map. What other services does Google make available? In fact, we've already used one this semester in our Control-Alt-PC. Joel? Okay, but there are weather APIs out there. So for example, if you want a weather widget on your site, the Weather Network has an API where it will read your location and show you the current weather. Yeah, sign in, right? Not only Google, what other providers make sign in available? Facebook. What else did you use in your assignments if you did the bonus? Twitter, Microsoft. So again, they're saying they're making it convenient for users. They'll give us as developers the API for free, but it means we're branding our applications with their stuff and making it available to their users. So an API really, kind of coming back to Tyler's definition of a messenger, an API is really just a way for two different applications to talk to each other in some way. So either we're leveraging functionality like Google search. Google says, here, you can embed our search in your application. Or maybe we want two applications that talk to each other in another way. Think about if we're shopping online. It was Cyber Monday yesterday. Who bought something online? Anybody buy anything online yesterday? Not one person? Okay, you're students, I can accept. Okay, so people are buying online. So if you think about a shopping cart, most shopping carts use an API at the checkout process. In fact, we did it in our store. What API did we use? Because there's functionality we wanted that we didn't want to write ourselves. We were going to use another service to do that for us. So what API did we integrate into our checkout? Right, we used the payment gateway API. We're not going to write the code ourselves to charge credit cards. We're going to send requests to a payment gateway API, and it sends us back responses. So this word is really old. Does anybody have any idea what it actually stands for? An API? Yeah, it's an application programming interface. It's a really old term that comes from the original development of Windows. So the idea of an API, when Microsoft created Windows, was they were creating all these little services that any application could use. So services would be things like save or print. So if you developed your own program, you didn't have to write your own functionality to save a file to the operating system. Microsoft said, here's an API, a little method called save, and if you just invoke that from your program, whatever file you have gets saved, stored permanently on the hard drive. If you want to print, you don't have to write your own print program. We'll build this service into Windows, you call print, and the operating system then takes it and handles it. So that's where this name came from. It's old. This is like from the late 80s and early 90s. And this has evolved into what Tyler's talking about, basically a messaging service. So we write an application and we can extend the functionality of our application by calling APIs. So there's two parts to an API. Largely, we've worked with them, but we've worked with APIs as a consumer, right? We've consumed other APIs. We've used Google's login service. We've used Stripe's payment authorization service. But sometimes we actually need to build our own APIs. Can you think of any reason what would be a scenario where we would need to build our own API into a web application? Okay, so okay, can you flesh that out a bit more?
Right now we're doing our thing has our product controller. We want to retrieve the product from the database.
Yep.
But not the same way as we do it. We're going to write that in a different application that we already have.
Okay, so that's a good example. Let's think about, we have the products in our store, but let's say we want to make, for our suppliers, for all the products we sell, we want to allow them to manage their products in our store. We don't want to give them admin access to our website because then they'd have access to everybody's products. But we want to allow them to add new products to our store or update their descriptions or even change their pricing if they want. We want them to do that in their application. But we could build a product API so they could manage the products in our own store without them having direct access. So we would build an API and they could interact with it. That would be a good example. Can you think of any other examples of where we might want to build an API or a service into our application so somebody else's application could communicate with it? And think of the whole life cycle of an e-commerce transaction. So there's got to be products in our store. People need to be able to shop, pay for them, and then after they pay for them, they need to be able to actually have that order fulfilled, and they need that product shipped out to them. So what might that look like in terms of dealing with third parties? Okay, so it could be that we want an API so that when a product gets shipped, the manufacturer can send us the tracking number and attach it to the order. So when our customer looks at their order history, they can then see the tracking number, which they can click on, which would then call the UPS or the FedEx or the Canada Post tracking API and show them where their order is. So in most enterprise solutions, I'll give you a few real world examples of what this looks like. I'm hoping, so this is the underlying architecture for one of the big bank's mobile applications. I bet you probably won't say which one, but there are probably people in this room who have this app running on their mobile device right now. And the project manager for this project is a colleague of mine. I'm actually hoping to have him come to class to Project Studio to do a guest talk sometime next semester. And this is part of his talk. This is what the underlying architecture of the mobile app looks like. So everywhere you see one of these containers, that's a separate application. So what do you suppose all of the arrows and black lines represent? Right, they are data flows. So what's used to handle the data flows? How are the data flows done between all those various components? Are you? Right, everywhere you see a black line, that's an API. So very few applications are built from scratch from the ground up. And very few applications are, particularly in the enterprise world, are comprehensive enough to do everything a business needs. They have a collection of components. They might buy some of them, pre-existing software, and then they have to custom write many of the other components that fit their business needs. And a huge part of what developers in enterprise organizations do is they're writing APIs to tie all these things together, right? How do we get the core banking to talk to our security layer, for example? So all these things underpin this one mobile app, right? How do we do interact direct payments? How do we do bill payments? How do we interact with mobile direct pay from like Apple Pay? So all these things are integrated. So if you go to work in a large organization like a bank or in government, when you're done here, this is probably a huge part of what you're going to do. So some of the developers are building these components, but a lot of them are about talking together. So what we want to build today is a really simple API in our computer store. And we can basically use scaffolding to generate this. So let's open up our shop. And what we're going to do right now is really all you need to do for assignment 2, part 3. In my Friday class, some people did it in 10 minutes before they walked out of class because Visual Studio makes it really easy. So let's open up our store. There's also a software tool that I've posted on Blackboard. Actually, there's a couple of them that I'd like you to install. So depending on what browser you use, if you use Firefox, I'm going to recommend installing this little extension called a REST client. If you're a Chrome user, there's an extension here you can install. And then I'd also, so you don't need to install both of these, install one of the first two. I'm also going to recommend you install this third item here called Postman. So Postman is a tool that allows us to make HTTP requests so that we can test APIs. Remember, APIs, they're just services. There's no user interface. There's no front end. So Postman allows us to interact with APIs. Basically, substitutes for a UI. And these tools will be helpful also for you to test your assignment 2 part 3 and make sure your API is working properly. So we'll look at how to use these tools shortly. No, you don't need to create an account. Yeah, you can just download and install it. So there's 2 forms of APIs, basically 2 protocols. And the one that's currently the standard is called REST, which stands for, I've got it up here, representational state transfer. So most APIs today are what's known as RESTful. And RESTful APIs, what it means is that the methods inside the name, they're sort of standard. And we typically use HTTP methods to describe what a particular method in an API would do. So we use methods that are familiar, like get for reading data, post for creating data. We have a delete method, which is used for obviously deleting data. And we'll see these actually, if we look here, we could actually have a look at COMP API. So let's look at a service like Spotify. Spotify has an API, so we could build a web application or a mobile app, for example, and we could connect to Spotify. So here's our app. Spotify has an API available, and it says the base address of this is api.spotify.com. It provides a series of endpoints. So what this means, if we have a look, here's their reference. So here are all the different sections within their API. So for example, if we want to look at albums, this is our URL. And in here, there are 3 different get methods. And this looks kind of similar to actually our MVC controller. We have a get method where if we pass in an ID, this will return an album. If we have a get method with an ID and /tracks, it'll then get us the individual songs on the album. And if we just have get albums, it'll return a list, kind of like our index methods do in our .NET controllers. So if we click on this, this will tell us, here's the URL. And if we run a get method, it wants us to pass in some kind of authentication token. And then it shows us what kind of response we get back. If it's successful, it'll give us a 200 OK HTTP response, and it'll give us a list of albums in JSON format. So REST APIs always use JSON. What is JSON exactly? You guys worked with it before, I'm sure. What is it? Yeah, it's JavaScript object notation. So just basically an array in JavaScript. And that's the standard format for all of these APIs. So everywhere we have these arrows, the data moving back and forth is in JSON format. Traditionally, we used a different format for APIs. We used to use an XML format instead. But APIs have moved to JSON because it's less characters, it's easier to read, So it's faster, it uses less bandwidth to send messages to and from APIs in JSON. And it did the same messages in XML. So we could actually test this. It actually gives us a test token here. Oh, we'd need a token, I guess. But it shows you a sample request and response of what the data would actually look like. And then it's documented with, it tells us, here are all of the individual fields you're going to get when you ask Spotify for a list of albums. So not only do we want to build an API, but then later on, we need to document it, because it's no good to build the service if we're not going to tell another developer of another program, here's how you interact with our API. Here's how you send requests, and here's what you can expect to get back. We have to build the API, and then we have to document it. So we can do this super quickly. So inside my controllers folder, in my web project, I'm just going to right-click, and I'm going to add a new folder. And I'm going to call the folder API. So we're going to make a controller, but that's not going to be a web controller. It's going to be an API controller. So I'm going to put it inside my controllers folder. Right-click controllers, add new folder. I'll call it API. And now I've got a subfolder here. And then I'll right-click my API subfolder, and I'm going to add a controller. So which one of these do you think we should pick? Yeah, let's pick the bottom one. We want an API controller that uses Entity Framework, and it will have REST actions for performing create, read, update, delete, and list. So I'm going to pick that last one. Click Add. It says, what model do we want to base this on? We'll pick our product model, and it'll automatically get named Products Controller. It's okay that we already have a Products Controller file with the same name, because that's in a different folder. So we can have two files with the same name as long as they're in different folders. So all I had to do here was pick my product model, and I'll click Add. So we'll let Visual Studio generate the controller. What we're doing right now is really all you have to do for part 3. It's 5 easy%. So we have our controller. Notice the route. So the path will be API/products. And it's defined as an API controller, meaning all of the methods, they just take JSON in and they send JSON out. It already has our database connection set up, just like our other controller. And if we look at the methods, we have a get method that returns a list of products. We have a second get method that takes an ID parameter, and this one will go look up that product and return. So this is like the API version of our details method. This one is the API version of our index method. So this gets all the products. This one gets one product. We have a put. This is our update method. Take an ID and a product object and mark it as modified and save. So this will update a product. Our post method is going to be used to add a new product. And our delete method will take an ID and it will remove the product. So I'm just going to build. We will take a break in a second. I don't need to make any changes to this. It should be functional. So I'm just going to start my application. And we'll just quickly check just the first method in here. Then we'll take a break and then we'll try out all the other methods and see how they work. And that's where our Postman application is going to allow us to try out all the methods in the API. So remember, there's no views attached to this. There's no pages to see. So I'll let this load. And then we'll try our API. So should load my home page. I'm going to browse to the URL localhost/API/products. So this should run the get method that lists all the products in our database. So I get all of my products and I get it formatted in this nested JSON object. So I've installed that REST client extension in my browser for Firefox. If you don't have it and you're using Firefox, the data looks like this. It's just raw JSON. So installing that little REST client extension gives me the option to nicely format where I could, contract any or expand. Or if you're using Chrome, that extension I put on Blackboard again allows you to format, to see this formatted nicely. And then if on the end of my URL, I put in a slash and any product ID, it'll now run the second get method in the controller where it just gets a single product. Rather than getting a list, if I give it an ID, it gives me everything. If I put in an invalid ID, our get method returns a 404 not found. As our code in our get method says, if the product with that ID isn't found, we return 404 error. So what we just did is actually all you have to do for assignment 2, part 3. Create a subfolder in controllers, right-click it, choose Add API Controller with Entity Framework, pick one of your 2 models, build the file. Done. One commit to GitHub will be sufficient. Don't worry about making multiple commits. Not necessary. Now, we're going to take a break here. We'll do 2 things when we come back. We've only tested the get methods. We're going to use Postman to try out the post, put, and delete methods. So we can add, edit, then delete a product. Make sure that all those scaffolded methods work properly. They should work properly, but we'll want to test them. And then we need to look at using a tool that will very nicely take our API and actually generate an API document for us. I'll show you some examples of other APIs where developers have manually created this documentation, but there's a kind of become a standard and we can integrate it into ASP.NET. So we can scaffold the API and then use the tool to document it. So if we wanted to open up our API to another developer, we just go, here you go, here's the link to the documentation. All hands off. We're just auto-generating stuff. Okay, so let's take a break here. We'll come back and we'll do that in about 10 minutes.